Alrighty. Welcome everybody. Thanks for coming on out today. We are going to talk about the prep work for Module 2 here today. But before that, just wanted to take a moment to just kind of remind you one more time of how things are going in this class. I'm sure you're all aware that the first homework assignment is due today. So hopefully you have already turned that in or are working on it and in progress and have a plan to get it turned in soon. You do have to demo that to a TA or somebody to have that turned in. So let me know if you have any questions about how that process works or anything. And then that's kind of how the process works. So, you know, we're going to be hopping into Studio 2 this Thursday, and you'll have another assignment for next week. Does anybody have any questions about the homework assignment? I'd be happy to answer any questions about the assignment or logistics about what's coming up on the calendar or anything like that before we hop into the prep work for today. Anything at all I can address? Okay. Then what I'm hoping to get through today is just, you know, as many of these exercises as we can possibly fit in the time that we have. This week we're going to be talking about control flow a lot. So a couple of different ways to control the way that our programs execute. So up until now, everything that we've seen, every program that we've looked at, all the examples are basically a straight line. So we start at the top and we just execute one line of code after the other from the top all the way until we get to the bottom, and then we're done. And that works well for some things, but you know, in life we oftentimes want to be able to make choices, make decisions. So I don't want to just do the same thing every time. I want to look at some values and maybe do this thing if this case is true, and do this thing if something else happens to be true. So we're going to look at some examples of how to do that today, and then later on, for the second part, we'll see how we can, an easier way that we can write code to repeat things for us, to do things multiple times. Because, you know, while we could just copy and paste the same chunk of code a bajillion times, it'd be much nicer if there was a way to make it more concise, consolidate it down. But let's start by talking about if statements. So if statements are what we use to control or to make a decision. You'll hear them referred to as conditionals or making a selection. It's really a choice. So I'm either going to do something or I'm not going to do something, where the decision whether or not to do something is based on a condition. So I want to start just kind of by reviewing some of the basic syntax for an if statement. Here you can see these are actually three different ways of writing if statements. Although I strongly dislike this way on the very far left here. I'm a big fan of either of these two options on the right-hand side. When I write my if statements, there's always going to be the word if, of course, followed by parentheses, and then inside the parentheses goes a conditional expression or a Boolean expression. Basically anything that can resolve to be true or false can go inside of there. So here you see a relational operator. It doesn't have to be a relational operator. It could quite literally be the word true, right? That's okay. It just has to be something that's going to be either true or false. Then after that, we see our good friends, the curly braces. And so everything that appears inside of these curly braces, that would be called the body of the if statement. So the way that these if statement works, if this condition evaluates to be true, I'm going to do this thing inside of here. And if it's false, then I'm not. I'm going to skip it. I'm just going to skip it. I'm not going to do it. And that's true regardless of how many lines there are in between these curly brackets, right? I do everything that's in between these curly brackets if that statement is true. And so that's a big reason why I really don't like leaving the curly brackets off. You can see that in some situations they are optional. You will never see me leave the curly brackets off of an if statement though, and I would really highly encourage you to do the same. Always put those brackets in. It just makes it visually stand out a bit more. And the other thing that I want you to pay attention to as well is the indentation that's happening here. That doesn't affect the code at all, right? It doesn't make it run differently or anything like that. But it does make it easier to read. Absolutely makes it a lot easier to read and understand what's going on. And so that's one of the first things that you'll see, if you come ask me questions, if your code looks like a mess, and that's going to be one of the first things I say is let's clean it up. Let's make it look nice. It's going to be a lot easier to understand what's going on if you see where things are clearly. You can visualize the structure of the code a little bit better. Okay? Great. Let's take a look at an actual example of an if statement in code, starting with, very simple example with a Boolean and a scanner asks us a question. Did you pass the midterm exam? And so here's an example of using our scanner to read in a Boolean value. The user is going to type in either true or false, hopefully, right? And then regardless of what they pass in, we're going to evaluate. There's actually two if statements here. So if pass exam is true, then I'll do this thing. And then this would be if not passed exam, or if pass exam is false, would be another way to interpret that. Then I'll do this thing. Okay? I want to point out that while we as human beings look at these and say, all right, we know for a fact that only one of these is ever going to work, right? Passed exam cannot be both true and false at the same time. It can only be one or the other, not both, right? So we know that this is only ever going to be one or the other. The computer, however, does not know that, right? And it is very naive about these sorts of things. It sees this very much as two separate if statements. These are each two distinctly separate questions that it's asking. Should I do this thing or not? Let me evaluate the condition. Should I do this thing or not? Let me evaluate the condition, right? It's going to look at that condition every single time and say, if it's true, I'm going to do it. If it's false, I'm not. And, you can test this. It's not terribly exciting, but of course, if you type in true, you can see that it does execute the top and not the bottom, right? So this statement never got printed out. If I typed in false, then we would have seen the opposite. But those are the only two options. Question?
What if you type in something that was neither true?
Yeah, great question. Neither true nor false. So the conditions don't, our if statement conditions don't account for that because, that's not, as far as they're concerned, something that could ever happen. But that's more of a problem for the scanner to take into account. So if I just type in some gibberish, right, there's our good friend error text. So we can't control what the people type in, unfortunately. Of course, we can strongly suggest and hope that the user types in something appropriate. Later on, you certainly will see ways that we can handle this a bit more nicely. But for now, you can just treat this as walking off a cliff, basically. It's just no good. Not a good situation to be in. Great question, though. And then I would actually say, though, that while you certainly can do things this way, it's actually far, far, far more common to see conditionals that might look something like this, where I'm actually comparing a variable to some value. So here I'm using a relational operator, asking if number is greater than 0, asking if number is equal to 0, right? Here we're actually generating random numbers. So this is actually a little bit of a review from some of the stuff that we saw last week. But I certainly hope that you can take a look at this line of code and reason through why it's generating random numbers from -10 to +10. I hope that that's something that you can kind of walk through because, hint, hint, we're going to be asking you to do something very much like this on an upcoming assignment. Absolutely going to be something you'll see popping up. Yeah?
This is semi-related, but you have comments throughout here.
Mm-hmm.
Should we be adding comments and how often?
Yeah, great question. So the question is, should we be adding comments? How often should we be adding comments? I do have comments in here. I would say that actually these examples are probably a bit more overly commented than I would expect because their purpose is to teach you things, and so they spell things out a little bit more than I would normally expect to have to do in a program. That being said, it's very subjective when to use comments. Some people will, in this class, I've seen students take it to an extreme where they want to put a comment in front of every single line explaining what that line of code does. And, you can, of course, do that. I'm not asking you to do that, though. That is not a requirement. I actually think that while it may be helpful for you in the short term to do such things, in the long term, that's actually probably a bad habit to get into. We do not want to comment every single line of our code Generally, we just want to comment the tricky parts that are worthy of a little bit more explanation. But that's subjective, right? What's tricky to you is not tricky to me, is not tricky to the next guy, so you kind of have to judge a little bit. Yeah, great question though. So yeah, here we've got two if statements asking if it's greater than 0, if it's equal to 0. And notice that while I don't actually have anything checking to see if it's less than 0, there is sort of an implication there, right? If it's less than 0, then it's not going to do either of these, right? Both of these would just not happen. And like before, we can see that these are written in such a way that we know that only one of these will ever actually happen, right? It's either greater than 0 or equal to 0, but that doesn't have to be true. I could certainly write two conditions that overlap. There's nothing stopping me from doing that, right? So be careful. I'm not saying that's a good thing or a bad thing. It can be a bad thing if you're, not expecting it to behave that way, right? If you're not careful. If you didn't intend to overlap, then that could be an unexpected behavior. You just need to be a little bit careful about it. And that kind of leads me into sort of the next thing that I want to talk about, which is the idea that, actually sometimes the paths that we have, the choices that we have to make are related. They are connected. So instead of having separate if statements for these paths, why don't we link them together somehow? Why don't we actually signify that these conditions are actually, related? They're actually connected. And so we have ways to do that. And I'm going to talk about that next. Any questions about this, though, before I move on to the next one? Yes? Of course. This one, I'm sorry, could you repeat that for me? Okay. Yeah, the math out here, right? So I think you just need to reason through what it's given to us in terms of the lower bound and the upper bound. So anytime you're faced with a problem like this, here we're kind of going at it from reverse, right? Normally I'd say, write a line of code to generate numbers between -10 to 10. But here we're kind of working at it backwards, seeing how we generate these values. But, the lowest value that math.random can give me is 0. So plug 0 in and see what number comes back out. That's guaranteed to be the lowest end of my range, right? I would hope it's -10, but you can do the math. 0 times 21 is 0 minus 10, right? And then the largest value that math.random can give me is not 1, but close enough to 1 to where we can substitute 1 in here and see what that math is going to give me, right? So 1 times 21 is 21, minus 10 is 11, and then when we take into account the fact that it's never going to give us exactly 1, it'll only give us, a little bit less than 1, it's actually not 11, but 10, right? Since it's exclusive, not inclusive. So that's always my recommendation. Plug in the lowest value and the largest value and see what happens. And if you're trying to work at it in reverse, this is always going to be the range, and this is going to be the starting point. -10 and -10. That's not a coincidence. That's not a coincidence. Yep. Cool. All right. Let's talk about else statements. So if we take a look at a similar example to what we saw before, or actually this is the exact same example to what we saw before, where clearly this can either be true or false, but never both, right? I don't need to actually state this condition. It's a little redundant to have to state it. It's not wrong, but it's a little bit redundant. And so instead of, explicitly spelling it out, we can use the else statement instead. So the way we interpret this is, if this value is true, I'll do this thing, but if it's false, then I don't need to worry about a condition. I'll just drop down here and do this, right? I don't have to ask true or false again. I just do it. I just do that thing. Or if we look at a more, numeric example, driver's test is the one that I want here. We ask the user to type in their age. If their age is greater than or equal to 18, then I say, all right, you can get a driver's license. But otherwise, so the implied condition, there's an implied condition here, right? It doesn't actually say what the condition is to get down here. But if it helps you to write it out, make it explicit, you could say, age is less than 18 is the condition that would be required to jump down to that else statement, right? either way, I want you to notice that regardless, I'm taking one or the other. Taking none of them is no longer an option. Do you see that? So I'm taking one or the other. Taking one or the other. Taking none of them is no longer something we can do here. Before, when I just had the if statement, no else, doing nothing was an option. Just skipping it all and going on, that was an option. But now that's no longer the case. And so that's why, it's still necessary sometimes to not use an else. And it's up to you as the programmer, right? To decide, are these conditions related? Should these be linked together using an else statement? Or are they distinctly separate conditions that should be evaluated separately? That's up to you as the programmer to determine and decide. And so then here we clearly have a choice between, we have two options, but all right, why stop at two? We can, conceive of situations where there are many different possible choices that we could potentially want to take. And so we can actually take this concept of using if and else and chain these together to have, as many conditions as we would like. So here's an example of what that might look like. So x is just an integer. You can see it's set up here at the top. If it's less than 0, I'll tell you that it's negative. If it's equal to 0, I'll tell you that it's 0. Otherwise, I'll do this thing down here, just like before, right? I have three options now, right? Guaranteed, absolutely guaranteed to take one of them, no matter what. Skipping all three is not an option. And just like we saw with the last example, there's an implied condition here, which is that x is greater than 0, right? I don't have to say that, but that's the implied condition. Are there any questions about that? So the way that these things are evaluated is from top to bottom, and it's important to note that, like we saw before, right? It's entirely possible for conditions to overlap. So here I can see that if x is 0, right? If x is 0, this condition is true and this condition is true. Correct? So that's totally fine. The computer's not going to complain about that. But you should be aware, right, that it's going to pick the first one that it finds. So if there's ever more than one condition that could be an acceptable answer, it's just going to pick the first one closest to the top that it finds. Yes? That's correct, yeah. You can only have one else, and it will always be at the end. It'll always be at the very end. So the else is basically the situation you're saying, if none of the above conditions are what you're looking for, then do this. Do this thing. And this else is optional as well, right? So, I can repeat this idea that if I take the else off here, we're back into a situation now where it's possible that I don't do any of these choices, right? I could just skip the whole thing if the conditions all evaluate to be false. This isn't wrong. Again, it's up to you. It's your responsibility as a programmer to make sure that you're choosing the structure of if statement that most closely matches the problem that you're trying to solve. That's what programming is, right? So being aware of the different parts of an if statement, how that affects the control flow, that's important to learn so that when faced with a problem, you can apply that appropriately. Yes?
So the overlapping condition is not, like you said, it'll take the first one. Does that mean it would only print out, like, for example, here the x is negative and then disregard the x is negative?
Yes, that's a very good point. Thank you for bringing that up. So it is going to match the first one that it finds, and then as soon as it finds a match, it's done. It does not try to keep matching after that. Thanks for clarifying. Yes, that's exactly right. It's going to find one and exactly one match. And so then a very common kind of situation that you might, this program has a mistake in it, right? It's a very classic problem. I'm trying to take a numeric score and convert it into a letter grade. So a 93 should be an A, right? Should be an A letter grade. But if you run this program, you can actually see that the grade that we get back out isn't an A, it's actually a D, which is a little bit confusing. If you look at the condition, especially this one right up here at the top, I can see, all right, 93 is clearly greater than or equal to 90, and then it says A down here at the bottom. So why am I seeing a D at the end? It seems a little odd. It seems like it clearly should be A. Well, I mean, you might know. You might have already looked at this and figured it out, but let's pretend that we're gonna try and fix this. We don't have any ideas. Let's just walk through the program and just see what it does, because now that we have these if statements coming into play, we're doing this conditional execution. We're executing some lines. We're not executing other lines. We'll actually be able to see that if we step through the code, right? We'll actually see it jump over some lines and execute some of the lines. So let's do that and see what happens. I'm going to start at the debugger. I set a breakpoint right here on line number 7, the very first line of the program. And so here we are. If I go ahead and step on through, there's my score variable set to be 93, just like I wanted. And then I create this string grade. That's I would call this quote might look a little silly. I would call that an empty string with nothing in it. Quote, empty string. Just initializing that to be an empty value for starters. Much like I would say, int something equals 0 if I wanted to. I don't know. Anyway, okay, let's take a look at the if statement. If score is greater than or equal to 90, which it is, very clearly is, right? I would expect to see it jump inside this if statement and change my grade to be an A, which, okay, cool. That seems good. It does, in fact, go in there and do that, right? And I can see over here the grade is, in fact, an A. So that's maybe a little bit more confusing. Then why did it print out D earlier? Well, let's keep going. The next thing that it's asking is if the score is greater than 80. Well, it is, right? It is greater than 80. That is, in fact, a true statement. So it's going to change the grade to be a B. Well, wait a second. That's not what... I don't want that. That's not what I wanted, right? And you can kind of see the pattern here. It's still greater than 70 and still greater than 60. So this is a very, very, very common mistake. For starters, we've got overlapping conditions all over the place, right? All over the place. There's this value of score matched many of these conditions. The problem is that I only wanted it to take one of these. And the way that I've written these, I've allowed it to take more than one of these options, because I have not given any indication that these conditions are actually connected or related to each other in any way. So I think the more proper way to do that would be to make sure these are all connected by using else statements. The way that it was written before, as originally given to you, was a whole bunch of individual if statements that were being executed independently of one another. By chaining it all together with else statements, I now have one big if statement, right? I'm going to go through that, find the first condition that matches, and I'm done. Do you see that? Again, the code that was up here before, I mean, the computer ran it, and there might be some situations in which you would want to write if statements like that, a whole bunch of them back to back to back, right? So it's really up to you as the programmer to identify, oh yeah, these conditions are actually all part of the same, check, the same decision. So I should actually link those together using else if statements instead of using separate if statements, right? That's your job as a programmer, to recognize that fact. Any questions? Any questions about that? Okay, cool. Then, I'm going to go ahead and move on to the next topic, which is something that I actually snuck in on you in studio last week. I know some of you may have thought that wasn't particularly nice of me to do, which you're entitled to, but I actually somewhat, I recognize that I kind of threw you a curveball by introducing, where did they go? The ands and or statements. They're on this page somewhere. Oh, I'm not on the wrong page yet, I'm sorry. The ands and ors, right? So yes, I do realize that that was perhaps a little bit unexpected, but I also think that that's just programming, right? I hope that you responded to that with curiosity, maybe got some help from TAs, maybe did some Googling, because that's programming. I'm faced with new things all the time, and the proper response isn't nobody ever told me what that is. The proper response is that's doing something. Let's figure it out, right? That's doing a thing. Let's see if we can figure it out. So, but let's formalize it. The two main compound Boolean expressions that you're going to run into are the ands and the ors, the or operations. There are other ones though, actually, but these two are by far the most common. And I want to contrast these with some of the other Boolean expressions that you were already familiar with, the greater than, less than, equal to kinds of Boolean expressions. Those are referred to as relational operators, checking to see how two numbers relate to each other. Whereas these compound Boolean expressions are used to join two things together. So the name and and or chosen in a very particular way. Here you can see that I'm looking at what's called the truth table for the and operation, where P and Q are both just Boolean variables, and then this is the result of the and operation. And the reason that it's called the and operation is because in order to get a true out, both P and Q must be true. So for an and operation to be true, both P and Q must be true. If one of them is false, if just one of them is false, the and operation will be false. The and operation will be false. The or operation is kind of the complement to that. I should start off by pointing out those characters right there, that's not an L, that's not a capital I. That character is called a pipe. I would imagine it's one that you've not seen or dealt with a whole lot before coming into this class. You get it by, it's right above the enter key on your keyboard, usually. The vertical line, it's called a pipe. I read that as just or, though. Whenever I see that, I just say the word or. So P or true is going to be true as long as one or the other is true. So as long as P is true or Q is true, then the result of P or Q is going to be true. Only if both P and Q are false will or give me a false result back out. Okay? Any questions about the ands and the or operations? Yes?
Why a question mark?
I mean, they are giving you a question.
Oh.
Yeah. Which I told you the answer to, but yeah. Yep. Now these are truth tables, right? These are called truth tables, and I'm generally not much of a fan of telling people to just straight memorize stuff, but you probably want to memorize these. This is a thing that's good to commit to memory. It's going to pop up all over the place from now until the end of the semester and beyond, as long as you program. So these are definitely good things to become familiar with. And so then to see an example of what that might look like in code, I mean, you hopefully saw a little bit of that in Studio last week. You can take a look at the Studio review. I talked about that a little bit last week as well. But here you can see this example is like, a little too close to home for me. I've been having arguments about cleaning rooms and doing homework with some kids at home these days. But, you know, if you clean your room and do your homework, it says you can go out, right? But only if you do both of these things. If one of these things is false, then you and I need to have a little chat, right? Honestly, if you clean your room and do your homework, you can do whatever the heck you want. I don't care. That's great. That is great. That is awesome. But yeah, so you can see the and statement requires both the left and the right thing to be true in order to do this. Otherwise, I'm just going to hop down to the else. Whereas or, the complementary, if I have to go somewhere, I'm trying to get to a destination. If it is within walking distance, or I have a car available to me, then I can go, right? But if it's not within walking distance, or I don't have a car available to me, right? If both of these things are false, then I'm stuck. I'm stuck at home. I can't go anywhere. So as long as one of these things is true, then I can go. Otherwise, I can't. Any questions about those operators? Any questions? So yeah, we more often than not use these to join two Boolean expressions together. So this is actually a lot of, very similar to what I would have expected you to see it kind of on the studio. Last week we asked you to do a problem called is ordered, where you were given three values, and to check to see if x greater than y greater than z. And the rude awakening that a lot of people get is they try to type in x greater than y greater than z, and the computer says no, you can't do it like that. You can't do it like that. You have to be a little bit more explicit, a little bit more verbose, right? And if you're confused as to why that is the case, consider that the way this operates, it'll say x is greater than y. That's either going to be true or false. And then you're left with true or false is greater than z, and that's, I don't know what that is. I don't know what that is. So we have to be a little bit more explicit. We have to say x is greater than y and y is greater than z, which is, means the same thing as what I had up there before. It's just now a little bit more computer friendly, a little bit more amenable to what the computer wants. So that's a very common way that we see ands and ors used to stitch these Boolean expressions together, like that. Alrighty, I'm about to switch over to loops. So this is last call for if statements for at least a little while before I switch over to that topic. Any questions about if statements, Booleans? Yeah.
I have a question about the not.
Okay, yeah, sure.
If I first write the if statement without the not sign,
Mm-hmm.
and then I put some curly brackets and some statements, and then else curly brackets and statements. If I add the not sign, then do I have to exchange the statements between the curly brackets?
Yeah, I mean, I think I can show that a little easier with maybe one of these previous examples up here. Oops. So like here, right? It's checking to see if it's true, and if it is, it does that, and if it's false, it does that. If I put a not out in front, and correct me if I'm wrong, you basically just flipped what happens, right? You just switched the choices. So now if it's false, I do this, and if it's true, I do this, right? So the not sign just flips the outcome. Yeah. Does that answer your question? Okay, good. Any other questions? All right. So if statements are great for making a choice. I've got options. I got things that I may or may not want to do depending on situations. Loops are used when we want to repeat things. So if I ever have things that need to be repeated multiple times, then I can use loops. And there are actually two different ways to do that. I'm going to start by showing you a while loop. So here is an example of a while loop, and actually the good news is that there's some similarities between while loops and if statements. So if I'll double back and read those comments in just a second, but I want to focus in on the while loop for just a second here. You can see that in terms of the code, what I write, the syntax is the same, except for instead of saying if here, it says while. Otherwise, you see that I've got parentheses, and inside those parentheses, I see a Boolean expression, something that's going to be either true or false, just like an if statement, right? Just like I would expect for an if statement. And then after that, I see curly braces, where the curly braces, just like an if statement, are going to tell me what to do if the expression is true. So if this evaluates to be true, I'm going to do the stuff inside of here. The difference The difference between a while loop and an if statement is that, if this is true and I do all of this stuff, I'm going to come back up here again and evaluate this condition again. And if it's true again, then I'll do that stuff again. And then I'll go back and I'll evaluate the condition again. And if it's true, I'll do it again. And I just keep doing that, keep doing that, keep doing that until this is false. So as soon as this is no longer true, as soon as this evaluates to be false, then I skip over this and I'm done. And I just go on and do whatever comes afterwards, whatever comes next. So an if statement evaluates the condition and will, if it's true, it'll do that thing, but it's only ever going to do it the once and then move on. Whereas a while loop is going to evaluate the condition and keep repeating this for as long as that condition is true. So with that in mind, let's take a step back and look at this program a bit higher up. There's three parts. There's three important parts controlling how this loop works. The first part up here is what I would call the loop variable. So we've seen this before. I'm just initializing a variable, setting it to be 1. Then you'll see that the condition depends on that loop variable. So there's the condition. That's the second part, the part that goes inside the parentheses, just like an if statement does. And then down here, the third part changes the loop variable. In this case, we're just adding 1 to it. I'm just incrementing, just counting up by 1. But those three parts are very, 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 very commonly found with loops. And so if we think about how this works, right, I start at 1. 1 is, in fact, less than 5. So I am going to go ahead and print out the number 1. And then I'm going to increment it, and it is now 2. 2 is less than 5, right? So I'm going to print that out. Add 1 to it. 3 is less than 5. 4 is less than 5. 5 is equal to 5, and that still counts, right? And then finally I get to the case where count is equal to 6, and that is now no longer less than or equal to 5. That evaluates to be false, so I'm done. I just hop out. And so if you run this, you'll see exactly that. The values from 1 through 5 are what get printed out here, right? The values from 1 through 5. And so hopefully you can see that, all right, if I want this loop to, operate a little bit differently, I could change this to be, -10 if I wanted to, right? And then I wouldn't get the numbers from 1 through 5, but I'd get the numbers -10 through 5, right? It would keep repeating. It's going to repeat more times now because it started at a different value, but the behavior is still the same, correct? As long as it's less than 5, keep adding 1 to it and repeating, keep adding 1, repeating, keep adding 1, repeating. Make sense? What about this? What if I decided to start my count at, what if I decided to start at 5? Can I do that? Let's see, why not? What's going to happen? How many times? Just one quote-unquote repetition, right? Just one repetition. In this case, you can see the number 5, and then you might know where I'm going next. What if I put 6 or 10 or 100 or any value bigger than 5? Nothing. Nothing's going to happen, right? The loop, it's just going to skip the whole thing. And yeah, that can happen. That can totally happen. Okay. And, I don't necessarily need to do it, but you can imagine I could tweak this value as well just to change the stopping point. And I could even change this value too, right? I could change this value. So instead of saying, count going up by 1 every time, I can make count go up by 2 every time if I wanted to, right? I could do that. So now instead of saying 1, 2, 3, 4, 5, it's going to say 1, 3, 5. So these three parts of the loop are all very important, right? The initializer specifies where I start, the condition usually specifies where I end, and then the third part down here, how I change the loop variable, is the gaps, right? How I'm counting, how much I'm jumping every time I go through the loop. Am I jumping by 1s, by 2s, by 5s, by 10s, whatever the case may be. I could actually, so here's an idea. Can I go backwards? Well, I can, but you have to be a little bit careful, right? I'm going backwards from where? I'm counting down by 2s, but I'm starting at 1. I'm going to count down by 2s until I get to 5. How long is that going to take? It's going to take a while, right? So this loop is going to go for a while. In fact, forever. It'll never get to positive 5, right? So if you find yourself in this situation, this little red square right here is how you would tell it to stop. You have to be a little bit careful. I mean, the more extreme example, actually, of that, and perhaps even more common, is what if I just accidentally apart? Right? Whoops, part 3, poof, gone. Just forgot to put it in, or maybe it was there, got deleted. Happens all the time, right? And so now what do I have? I've got a magical program that just prints out, 1 from now until eternity. Quite literally forever, right? It's infinite. This is an infinite loop. That's what we would say. This is an infinite while loop. Will run forever. Usually not what we want, right? We can do this. Usually not the desired outcome. In fact, the point of this whole little exercise is to show you the idea that while these three parts are important, it's your job as the programmer to make sure that this condition here will eventually be false, right? This condition should eventually be false. Will it take 10 times to get there, 100 times, 1,000,000 times? I don't necessarily even care how many times it takes to get to be false. It's just got to stop eventually, right? It just got to stop. Got to stop eventually. There are exceptions, weird, rare exceptions to this rule that you might see pop up from time to time, but in general, we do like for our loops to eventually stop. And it's our job to make sure that our loop variable moves in the proper direction towards that goal. Any questions? Yeah?
Instead of stopping the loop at the point where something that it's resulting in reaches a certain value, is it possible to just say run this loop some number of times regardless of what it gets to?
Well, so I think that's what this loop is actually doing. So I'm interpreting your question maybe a little bit differently than how you asked it, but I think I kind of get what you're going for. The way that this loop is written, for any combination of numbers here, right? You could imagine I can generate any dang loop that I want to that counts from any number to any number going in any direction with any gaps, right? I think maybe a more general idea of a loop would be to say, I don't care what the numbers are. I want you to keep doing this thing until this thing happens, right? Period. And so that's possible to say as well, right? Where you may not know how many times it's going to take. If I'm using the numbers like this, I can tell you how many times this loop's going to run every time, right? I just have to do the math, and I can figure it out. But there might be some times when the thing that I'm waiting on is going to take some undetermined amount of time, or is just expected to happen at some point in the future, where that some point in the future could be a minute from now, an hour from now, tomorrow, and I just have to be ready, right? Whenever that case may be. That's a more pure style of a while loop, where it's just based only on a condition. Yeah. Question? So your question is, can I do this? Yeah, so unfortunately, I kind of see where you're going for here. Unfortunately, I don't think this can ever be false, right? Because this is going to be evaluated, on the spot for whatever the given value of count is. So well, pick a number for count that makes this evaluate to be false. I don't think it's possible.
So if you wanted, you would have to set a new variable and have that variable always be some number of the initial count.
You could, yeah. So if you wanted to, so I mean, if having the maybe, and correct me if maybe I'm going in a different direction than what you was thinking, but you know, could I just do something like this and then just say like this? Yeah, like this is totally fine. I don't know if that's kind of the direction you were headed in.
Yeah, you could set n to be count plus 5%.
Oh yeah, up here. I mean, yeah, if you wanted to. Yep. Absolutely. Yeah, absolutely. You certainly could. Any other questions? So, yeah, with the, yeah, here's that's an infinite loop. So this structure of a loop, it turns out, is so common with the three parts: the initialization, testing the loop variable, and then changing the loop variable. That turns out to be such a common way of approaching loops that there's a whole different structure, loop style, built just to accommodate these kinds of loops. So yes, I showed you how to do this with a while loop, but actually a for loop, let me put this back to its original form. Here we go. A for loop, so this for loop written here does the same exact thing that the while loop did in the previous example, and the three parts are still here. You'll notice that the for loop just kind of gathers them all in the same place, so you can see them all in one spot, and they're not spread out all over my program. You know, in this small example, it was pretty easy to see where the three parts were, but you could imagine in bigger programs it might be a little bit harder to track down where that is and see how that loop's running. So for loops keep it all for us in one place. Here's the initialization, the loop variable initialization. Here's the condition, and here is our loop variable update, right? What kind of maybe can throw people off a little bit is that, you know, the execution of this can feel a little awkward, but like this is only ever going to happen once at the very beginning of the loop. It's initializing the loop variable. This is the starting value, right? Starting value is 1. And then we evaluate the condition. We do the thing in the loop. If the condition is true, we do the thing in the loop, and then we do this at the end of the loop. So this happens at the beginning of the loop, and this happens at the end of the loop. That control flow can be a little bit tricky, but you know, I would encourage you to run it through the debugger a few times if you need to, until you get used to how those for loops are operating. I can show you real quickly here with this example. Did it not stop? Oh yeah, I hit the wrong button. Whoops. So there's my loop variable count set equal to 1. Go ahead and print out that 1, and now it's about to increment count to be 2. Right? After it increments count to be 2, it's going to check the condition again. So 2 is still less than 5. So the next time that I step, I'm going to see that count is now 2, and then it's going to evaluate the condition and just say, yes, that's still true. So I'm going to get ready and print out this value again, and now go back up. I'm going to increment count one more time, and you can see here it's repeating, right? You can see the repetitions. 4, 5, count is now 5. Now this is the last time. It's about to increment count again to be 6. Once it evaluates the condition for 6, that'll be false, and you can see that I've not gone in the loop. I've jumped to the end. I'm out of the loop now. And so just like we saw before, you know, if you want to change the way your loop variables, your loop runs, right? Now all of your stuff's just right up there at the top. I can set the initial value, the ending value, the increment, and I don't have to track all those pieces down in my code. Does that make sense? Any questions about that? And so now actually you have another choice to make as a programmer, right? If you come across a problem and you've determined that the problem requires repetition, some form of repeating, right? You know that you need a loop, but which loop do you use? Do you use a while loop or do you use a for loop? The good news for you is that in a very large number of situations, it does not matter. You'll be able to use either one to get you there. So you should pick whichever one you feel the most comfortable with, whichever one, makes the most sense to you. That's the one you should pick. There are cases, however, where, a while loop is a very obviously much better choice, or a for loop is a very obvious better choice. Those situations do happen, and we'll be sure to try and point those out to you when they come along. Right? In general, though, if you know how many times you want your loop to run, for loop's a pretty good choice. If you don't know how many times, like I can't say an exact number, like I want this loop to run 10 times, so that's a good for loop, right? I want this loop to run until this thing happens. How many times will that take? Well, I don't know. I have no idea. That's got while loop written all over it, right? That's a good time to use the while loop if you don't know how many repetitions it's going to take. Yes?
Let's say you want to loop it 10 times, how do you convert that to a for?
I mean, there's more than one way you could do it, but it honestly could be as simple as that.
But then, like the initialization, if the initialization is different, then it would run a different number of times.
Correct. Yeah,
Okay.
that's true. Yes. Now, I kind of see maybe where you're going with that a little bit, and I would counter with that. Usually, actually, what I'm iterating, it's usually the number of iterations that I want is actually not 10. I mean, maybe sometimes it's exactly 10 or 15 or something like that, but usually the number of iterations that I want is more like the number of letters in that word, or the number of items in this list that I have. It's a more general value, not just a specific number. And so I'm going to be writing those loops with those generalized values in mind. Exactly, yeah. You'd be using a variable here instead of just some number, and the loop will adapt to whatever that variable is. That's what we're going to see. In fact, we'll see an example of that in just a few minutes, as a matter of fact. Any other questions about for loops? Okay. Yeah, so this find and replace example, I'm actually going to briefly mention it real quick, but I'm not going to go through it only because, I mean, it's a little bit complicated. However, this is a great example of a problem where I would say a while loop is a much better fit for a for loop. However, I actually want to look at this reverse string problem instead. I think this is actually a bit more of a better example for what you're going to see coming up on homework assignments and such. So I'm going to focus on this one. Here I'm using loops to work with strings. So I was actually just talking about this, right? I want to write a loop that will go through and visit each letter in a word, for example, in a string. Okay, well, you'll see here that my loop variable is starting at 0, which might seem like a little bit of an odd choice. However, consider that in computer science, the first of something is actually stated to be at position 0. So I'd actually say that this H is in position number 0, and the E is in position number 1. We actually have a word that we use to refer to that called the index. The index of H is 0. The index of E is 1. The index of O would be 0, 1, 2, 3, 4, right? 4 would be the index of the O. So we always start from 0. That's going to happen over and over and over again. You'll see that again next week as well. So for my loop, I can say I starts at 0. I is less than the length of the string, where the length is quite literally, how many letters are there? So there are 5 letters here. I, if it's going to be less than 5, means that it could be 0, 1, 2, 3, 4, right? That's actually good. I don't want it to be 5, because if I tried to look at the letter at position 5, there is no such letter, right? That would take me off the end. Do you see that? Because I'm counting from 0. Start from 0. There are 5 letters, but the position of the last letter is not 5, it's 4, because I'm starting from 0. So my loop is going to run from 0, 1, 2, 3, 4, and then it's going to pull out I would pronounce this as the ith letter. So if I is 0, it'd be the 0th letter. If I is 1, it'd be the first letter. 2 would be the second letter, right? It's using substring to pull out the letter between I and I plus 1. So between 0 and 1 would give me the 0th letter. And I want to run this through the debugger too, so you can very clearly see how this works. I know that this is actually reversing the string. I actually don't even care about the reversal of the string. The more important part of this example to me is the fact that you can use a loop to go through and visit each letter of this string one at a time. I think that's the most important takeaway here. So let's take a peek and see exactly what's going on. You can see there's our string s, which is set to be hello. I've set it right at the loop. And so now there's our loop variable I, which is a very traditional loop variable name, by the way. You'll see that happen a lot. Set to be 0, and it's going to pull out the letter at position 0, which is, there's the big H right there. And it does the reversal stuff, which again I don't really care about. And then I goes up to 1, so it pulls out the letter at position 1, which is the E, right? And then it pulls out the letter at position 2, position 3. So I've now written a loop to go through and visit each letter of my string. So yeah, like I said, here it's reversing stuff, but you know, you can do whatever you want. You can count the letters as they come through, or whatever the case may be. Whatever you actually want to do. Yeah.
When it says s dot set string I comma I plus 1, does that mean it's taking the part of the string that is starting at index I until index I plus 1?
That's
Or is it
correct.
just taking whatever index I is?
I to I plus 1, but it's exclusive on the upper end, just like math.random is exclusive on the upper end. Yeah, that's a common pattern too. So include whatever the beginning index is, but exclude the ending index. So give me all of the letters between 0 and 1, inclusive of 0, but exclusive of 1. Just gives me the single letter. Yep, that's the way to interpret that statement. Great question. Any other questions? Yes?
So that means that you would do like I plus 2 and return.
It would give you 2 letters back, that's correct. In fact, I mean, if you want to play around with this example, you can see that the reversal doesn't work so hot if you do stuff like that. It'll break it a little bit, or it might even crash the code. Yeah, I was worried about that. Oh, 12, whoops. Yeah, well, maybe that's why. It's a little big. Is it gonna crash still? Maybe. Yeah, it's gonna crash. I think it just goes too far. It goes off the end. It goes off the end of the string. Anyhow.
Unless you told it to stop when code s dot length.
Oh, yeah, you
I
could.
is less than s dot length minus 1.
Yeah, you could try and stop the loop one earlier. Let's see. Oh, there we go. Lolella. That's kind of funny. It reversed it in chunks of 2. Yeah. I don't know what that is. Anyway. We broke it in a fun way. I like breaking things. I do think it's fun to break stuff. Great question. Any other questions? I'm gonna do it on time. I got 20 minutes. All right, cool. Oh yeah, question.
If you wanted to like decapitalize all the letters and take like just one string color.
So that's a great question. Strings actually, there are ways to do other things with strings other than what we've seen here. So, you know, we've seen s.length to get the length. We've seen substring if I want to extract part of a string out. But there's other stuff that's available. So if you type in the name of a variable followed by a dot, it usually provides you a list of operations that can be performed on that. And so you'll see the things in there that we've seen, like substring is on here somewhere, and length is on here somewhere. There's length, right? So those are all on there, but you can see there's a whole lot more, a whole heck of a lot more. And one of these is probably going to say, there's one, 2 lowercase. And there's probably another one like 2 uppercase. So, you know, using some combination of those, you could achieve whatever you're going for. Yep. Great questions. Any other questions? Okay, so I've shown you if statements, which we use to make decisions. I've shown you loops, which we use to perform repetitions of things. Now, for most of the examples that I've shown you, it's just had one loop or one if statement, maybe a couple if statements. But in real life, our programs can get quite complex, and I'm not just limited to one loop or one if statement. It's possible for me to have lots of loops and lots of if statements in a program. In fact, it's possible for me to have a loop inside of an if statement, or an if statement inside of a loop, or a loop inside of a loop, or other combinations, whatever combinations of these things that you might come up with. These are all possible things to do. So it's important to understand what the implications are when you see those things show up. I want to show you, in particular, this is maybe one of the more complicated structures, one of the more complicated combinations that we see, called nested loops. So when I have a loop inside of a loop, I do want to point out, though, I'm not showing you an example of an if statement inside of a loop, but that's definitely doable. I can put an if statement inside of a loop, or a loop inside of an if statement, and you may be asked to do that very thing on a homework assignment, for example. But let's take a look at this loop inside of a loop. The way to interpret this, if we think about what this code is doing for us, you can take a look at this first one. I see row is going from 1 to 3. Okay, so row starts out at 1, and then I have this other loop inside of here where column is going from 1 through 5. Those names were chosen, intentionally, and they do give you very big hints, I think, as to what these loops are what the role of each of these individual loops is for us. But let's walk through this one in the debugger as well, and I really want to make sure we get a feel for what the execution of this nested loop structure looks like, because you're going to see it over and over again. So here I see my row loop variable from the first loop is set to 1, and I'm about ready to hop into the second loop, right? So 1 is less than 3, that is in fact the case. And now I'm going to create column. Column is 1, column is less than 5. All right, so here I see row is 1, column is 1. So far so good, no surprises. I print out the asterisk, and now I'm still in this innermost loop, right? I hit the end of this loop, and it goes back up to the innermost loop. And if I make one more step, I see that column is now 2, but my row has stayed the same. Row did not change. So my row is going to be held constant while column counts up. Or in other words, this outer loop is waiting for the inner loop to finish, right? The inner loop is going to go through all of its repetitions before this outer loop considers its first repetition to be finished. I hope that makes sense, right? So I would expect to see 5 repetitions here, 3, 4, 5. There's my 5 stars appearing at the bottom. And now I'm done with that loop. You can see it didn't go back in the loop again. It jumped down. And now, after I execute this, I finished the outer loop for the first time. So I expect to see row go up to 2, which it does. And look where I am. I'm on the inner loop again, and I'm going to do that. I'm going to do the inner loop again, right? That kind of makes sense. The outer loop is saying, I want you to repeat this inner loop 3 times. The inner loop repeats 5 times. So if I'm repeating this 5 iteration loop 3 times, that means I would expect to see 3 rows of 5 stars, right? This outer loop is quite literally telling us how many rows I expect to see, and the inner loop is telling us how many columns I expect to see. So if I follow this through to its completion, there's my 3 rows of 5 stars, right? 3 rows of 5 stars. I think this is a great way to write something like this. Choosing your variable names appropriately, right? Having those named row and column is a very good reminder for you. This loop is going through all the different rows. This loop's going through all the different columns. Also pay attention to how the print statements are used. There's two different kinds of print statements, right? As long as I'm on the same row, I use the regular print without the ln, because ln moves me to the next row. So you don't see the ln used inside of this loop, because everything that's in this loop is in the same row. All of the columns are in the same row. Only after I've printed out everything on that row do I tell it to move on to the next line. Or the other way of thinking about this is that since this loop represents what row I'm on, and I know I want to move down to the next row once I've finished the current row that I'm on, you'll see that this statement appears at the end of the outer loop, right? At the end of the loop that represents the row, to say that this row is now over, move down to the next. I hope that makes sense. Hope that you follow. Are there any questions about that? Because this is a very important, very, very important structure. You're going to see it come up again next week. I mean, probably for a while. And like last time, like we saw with the other loops too, if you want to change the size of the stars that are getting printed out or whatever, you can manipulate the rows and columns accordingly, right? When we talk about arrays next week, looking a little bit ahead, we'll see this structure used a lot with arrays, but yeah. Okay. And then I think there was at least one or two. Okay, yeah. I think this might be the last example for today. Here is, so all of the examples that I've shown you, up until this point have been sort of, the simplest, most straightforward ways of approaching these things. And this is meant to be something that's a bit more realistic, perhaps, right? I'm creating some variables. I've got a while loop that's a little bit more complicated than what we've seen thus far, but let's see if we can work it out. Let's see if we can step through this and work through this problem. Actually, I want to start with some different variables here. Okay, yeah, 3 and 2. I really like using the debugger when trying to understand code, so I'm going to just hop right into the debugger here. Breakpoints right on the first line of the program, and I create a couple of variables to start with. So you can see variable 1 starts at 3, variable 2 starts at 2, and then I come to this somewhat complex conditional here. But let's work it out. If variable 2 is not equal to 0, all right, 2 is not equal to 0. That's a true statement, right? So this section so far is true. And variable 1 divided by variable 2. All right, let's do that first. So 3 divided by 2 is what? 1. It is an int. Yeah, good. It's 1. It's just 1. Not 1.5, but just 1, because these are both ints. So if 1 is greater than or equal to 0, that's actually also true, right? 1 is greater than or equal to 0. So I've got true and true, which is true. So we're good. I'm going to go do the stuff in the loop. Right? Let's step. There we go. I'm in the loop, and I'm going to add 1 to variable 1 and subtract 1 from variable 2. You can see the updated values over here, my variables window, and now I'm going to evaluate this again. Variable 2 is still not equal to 0. 4 divided by, well, that's an easier division. That's going to be 4, right? Which is greater than or equal to 0. So that's true and true. That's still going to be true. I'm still going to go in this loop, and I'll update my variables again. That becomes 5. That becomes 0. If variable 2 is not equal to 0, well, that's now false, right? Variable 2 not equal to 0 is now a false statement because it is equal to 0. And you might be saying to yourself, well, there's a little bit of a problem over here, right? Because if variable 2 is 0, then this looks very tricky. But I want you to remember that for an AND statement to be true, both the left and the right-hand side need to be true. So the fact that we have already shown this to be false means that everything that comes after here literally does not matter. In fact, the computer is smart enough that it won't even look at it. If it looks at this first half and says, oh, that's false, it won't even bother checking. It won't waste its time. So we don't need to worry about that sneaky division by 0 that's potentially lurking in there. The fact that variable 2 is equal to 0 is enough to terminate this while loop, and if I step again, you'll notice that I don't go in the loop. I jump right over to the end. Loop's finished. So that's a really, I think, good example of, the way that you might approach deciphering these loops when you encounter them out in the wild, because it's not uncommon to see conditions that look this complex or even crazier. Although, that being said, right, if you do find yourself in a situation where you're writing a condition and that condition starts to get a little bit long, right, you can totally break it up and make some variables and insert some variables into this expression to make it a little bit easier to understand. In fact, I would say that you're somewhat obligated to do that after a certain point, right? If the condition's going, off the edge of the screen and out the window, then okay, yeah, time to break it up. Question?
If you change it from and to or, it would go 1 like that, right? That's the 1
Yeah, so if you change it from and to or, now both of these have to be false in order for that to be false. Will that work, though, with the division by 0? Like, what's it going to do with the division by 0? I don't know. Yeah, there we go. There it is. Division by 0. It doesn't like it. It can't do it. You can't do it in math class. Well, you can't do it here either. Computers aren't any better at dividing by 0 than we are. So, yeah. Doesn't like that. Not a good situation to be in. Great question. Any other questions? All right. Well, I think that's it for me. I'm going to go ahead and wrap it up, but I'll happily stick around if you have any more questions. You want to come up and chat with me for a few minutes. Otherwise, I hope you enjoy the rest of your week, and I'll hopefully see you in the labs on Thursday for studio. Thanks.